Hello and welcome back. In this video, we are going to look at fractional average pooling, and this is the similar to the fractional max pooling that we have looked at in the previous video. For fractional average pooling, again, what we need is a ratio. So the ratio is equal to number of rows in the input divided by number of rows in the output. And in this case, we know the number of rows in the input, which is this input, and we know the ratio because we have specified it here for the rows, which is 2.3. And so what we can do is find the value for the number of rows in the output. So the number of rows in the output would be number of rows in the input divided by the ratio, and the number of rows in the input we have is 6, so we have 6 rows right here, so we put a 6. Ratio is 2.3, so we put 2.3, and then we need to calculate the fraction, and so the value we get by dividing 6 by 2.3 is 2.6. So what we need to do is take the floor of this, floor of 2.6, so we get a value of 2. Likewise, we can calculate the values for the columns. So number of columns in the output is equal to number of columns in the input divided by the ratio, and the ratio here is 2.3 as you see. So that is going to give us a value of 3 divided by 2.3 is equal to floor, and then we have 3 divided by 2.3, that gives us 1.3. And now if we take the floor of that, we get a value of 1. So if we were to write the output, uh, our output shape is going to be 1 for the batch, 2 for the row, 1 for the height, and then we have 1 for the channel. So that's going to be our output shape. Now to be able to get that output, what we need is a a way to split this particular tensor along the rows and columns to perform the average pool operation. And to do that, what we need is the row pool sequence and the column pooling sequence. So row pooling sequence is equal to, uh, so we need to specify the indices. So if we were to, if our output has 2 rows, then we would have to split this particular array into 2 parts along the rows. So I think 2 equal parts could be these. Here we can create equal parts because we have a value 6, number of rows is 6. If the number of rows were not 6, let's say if it were 5, then the parts would have been unequal. So we have these, and so the indices of the rows are 0, 1, 2, and then we have 3, 4, 5, and 6 is not there in that particular row index, but we specify that because we will be using it. Then along the columns we have 0, 1, 2, and 3 is outside. So the first set would be described by rows starting at 0, and we go all the way up to 3 but not 3. That means we include 0, 1, and 2. Let's just put a 3. And the second set starts at 3, goes all the way up to 6, but does not include 6. So we have 3, 4, 5. Put a 6 here. And so if we keep going, we can now write the column pooling sequence, and this is going to go in this direction. We have just one column in the output, so we just need one set created from the number of columns we have here, and if we just need one set, we simply start at 0 and go right up to the end, and we need the column at index 2, which is this one, so we put index that is one larger than that, so we put a 3. That is to say, we start at 0, go all the way up to 3, but not 3. Now, to perform the average pooling operation, what we would have to do is take all the values inside of this first set, where we say we start at 0, go up to 3, start at 0, go up to 3, and then get the average of all these values. So let's see how we could do that. Manually, what I'll do is create a cell up above here, or maybe not. That's the idea, because we could do this. It works. So what we have is 1 plus 2 plus 3 plus 4 plus 5 plus 6. Oh, sorry, typing on keyboard, that is connected. 1 plus 2 plus 3 plus 4 plus 5 plus 6, and we have to go up to 9, so plus 7 plus 8 plus 9, and that we divide it by 9, because we have 9 values in there, so that will give us the output, which is 5. So we could write here that the first value what we would have in the output tensor, let's write down here, we have a value of 5, that's the first value, then we'll have a second value. So for the second value, the values that we would have to look at is going to be these set of values that are below. We start at the index 3 and then go all the way up to 6, but not 6, and then all the columns. And now if we were to uh, type these out, we have all the numbers starting from 10 to 18. So 10, so let's type 10 plus 11 plus 12 plus 13, 14, 15, 16, 17, and 18. So those are the values we have. We again perform the calculation and we get a value of 14. So let's write down 14 in the output. That's the 14. So this again has the shape 2 by 1 that we would have expected, and we have the values 5 and 14 in here. We could now go ahead and run the code. So let me clear this part of the screen. And for performing the average pooling operation, the code stays the same, except what we are doing is we are changing the word here. So we say tf.nn.fractional underscore average underscore pool, and then we specify the value of x, specify the ratios. So the first ratio and the last ratio is 1. So these are all float values. And then in here we have the fraction or a ratio for the rows, and then we have ratio for the columns, which is 2.3 for both of them. So when we run this, here is the output we get. Oh, so something did not work. Maybe I made a mistake. 2.6. Oh, well. Let me go ahead and run this again. Probably that cell was not run. Okay, now we are good. I think it took the values from the previous one. So what we have here is output shape of 1 by 2 by 1 by 1. That's what we have, 1 by 2 by 1 by 1. Then the output shape, the output tensor is 5 and 14. So we have 5 and 14. The row pooling sequence is 0, 3, 6. So that's what we have, 0, 3, 6. Column pooling sequence is 0, 3, and that's what we have, 0, 3. Why don't we do one more example in this? So let's clear this part, and I'm going to just clear this output tensor here. and what we would can do is remove that, and we'll use a different ratio. Rest of it we'll keep it as is. So it's these, and remove all of that. So if we scroll back up to the tensor that we had, is this one. Let's use a ratio of a different ratio this time. Has to be greater than 1. So we put a value of, let's say, 1.1, and the for the columns, let's put another value of 2 2.1, something like that, and around this. So that's the new set we are going to work with. For the ratios, here we put a value of 1.1, and what that gives us after calculating is 6 divided by 1.1 divided by 1.1. We get a value of 5.45. 5.45, and if we floor that, we get a value of 5. Likewise, if we use the columns, and if we the column ratio we are using is 2.1, so we divide 3 by 2.1, we get a value of 1.42, and if we take the floor of that, we get a value of 1. So the output shape is going to be 1 by 5 by 1 by 1, and this allows us now to calculate the row pulling sequence and column pulling sequence. Again, the row column index is 0, 1, 2, and then 3 is outside. Same thing for rows. We have 0, 1, 2, 3, 4, 5, and 6 is outside here. Now, the way we would want to split, we need 5 splits, but it's not going to be equal this time. So the way TensorFlow does that is random, in a random order. The way we'll do it is we'll start at 0, then 0 up to 1. We'll make that as the first sort of set, and then we go from 0 up to 2, 2 to 3, 3 to 4, and then 4 to 6. So we have 1, 2, 3, 4, 5. 5 sets for rows, and for columns it is just one set. So we start at the very first column, go all the way up to the last plus 1. So we need to include the last column, hence the plus 1. So we have 0 to 3. Write that again, 0 to 3. And if we were to perform the calculation now for average, calculating the averages, here's how we would look at it. The first block is going to be starting at the row with index 0 going up to 1. So essentially saying that just use row with index 0. Then start at column 0 and go all the way up to the column with index 3. There's no such column. Essentially we stop at before 3, and so that's just telling us that include all the 3 columns, and so that's the first set. Now we need to take the average of this. So this is going to be 1 plus 2 plus 3. So 1 plus 2 plus 3 divided by 3, and so we get the average value of 2. And I'm going to write that on the right hand side here. So that's the first value we get, and we'll get a second value, third value, fourth value, fifth value, and that's going to be the output tensor. The second set is going to go from 1 to 2. So the values we have are from here to here, and again all the columns. So 4 plus, so we have 4 plus 6. 4 plus 6 is 10, plus 5 is 15, and if we divide 15 by 3, we get a value of 5. So we put a 5 here. Let's keep going. The next set we have, we start at 2 and then go up to 3. So we have these values. And again, we perform the addition here. We get a value of 24. We divide that by 3. We get a value of 8. And I'm going to put the value here, 8. Likewise, keep going. We are going to use this set. Here we have the values of 10 plus 11 plus 12. We get a value of 33. We divide that by 3, get a value of 11. And so we are going to put 11 right here. And finally, the values that we would get for this set is going to be the average of all of these 6 values. Type those in my calculator. 13 plus 14 plus 15, 15, 17, 18, and that gives 93. If we divide 93 by, this time we have 6 values, so we divide by 6. So that gets us a value of 15.5. So let's write 15.5 here. And that is the output tensor we have calculated manually. Now, when we run the code below, we just need to note that we may not get the same output because the row pooling sequence and the column pooling sequence can be random. So let's go ahead and run this. And we do see that it is different. It is 1, 3, 4, 5, 6. Let's try and run this again. 1, 2, 3. Okay, so now we have 0, 1, 2, 3, 4, 6, and that's what we had used. Let's compare the outputs. And for that, we have the output shape is 0, 1, 5, 0, 5, 1, 1. So that's what we have, 0, 5, 1, 1. The values in the output are 2, 5, 8, 11, and 15. So we have 2, 5, 8, 11, and 15. So that is rounded off 15.5. Floored, I think. A row pooling sequence is 0, 1, 2, 3, 4, 6. We have 0, 1, 2, 3, 4, and 6. And the column pooling sequence is 0, 3. So we have 0, 3. And so that is how another example where we can use fractional average pooling. So I hope this video gave you not only the intuition of how this works, but also how to implement it in TensorFlow. If you have any questions, comments, or suggestions, please do let me know in the comment section below. I hope to see you all in next video. Thank you.